Hello students, welcome to my channel Mathematics for All. So insofar we have learned what is rational numbers, insertion of rational numbers between two like fractions, unlike fractions and two integers, then rational numbers as terminating decimals and non-terminating decimals, and finally conversion of non-terminating decimals to p by q form. Okay. Now today we will be learning what is an irrational number. Irrational number, a number which is non-terminating and non-repeating that is called an irrational number. That means we cannot express this number in the form p by q. We can't express such numbers in the form p by q, right? So what are the examples of such number? Root over of any prime number, for example root 2, root 3, root 5, root 7, and because we know that root 2 is 1.414213 and it goes on and on. It is non-terminating and at the same time it is non-repeating. No block is repeating. It's not that 4 1 again 4 1 again 4 1, so nothing is repeating. There is no repeating blocks. Similarly, root 3 can be written as 1.732 050,807 and it will continue. Then there is pi. We only know till 3.14, but not that. In nowadays supercomputers are computing pi up to I think some 1000 or more than that places. So now you can imagine, so its pi has been calculated to so many places and there is no repetition. Okay. Then there is a number e is 2.74 and then something on. These are called the transcendental numbers, but we are not going to all those jargons and that's not there in the syllabus. So square root of 2, square root of 3, that is, we can say that numbers which are not a perfect square is an irrational number. Similarly, numbers which are not a perfect cube, so we know that cube root of 64 is 4 into 4 into 4 gives me 4. So this is a rational number, right? But a cube root of 63, this will also be an irrational number. This will be an irrational number. So the numbers which are not a perfect cube, perfect square, these are all irrational numbers. Now some properties of irrational numbers. Properties of IR numbers. What are the properties? First property is the sum of a rational number. If we operate rational number and an irrational number operate means I do addition or subtraction or multiplication or division, any of the four operations, I will get irrational number. So 4 plus root 3 is an irrational number. 4 into root 3 is equal to 4 root 3. This is an irrational number. 4 by root 3 I can still rationalize, and root 3, this is still an irrational number. So addition, subtraction, multiplication and division of a rational number with an irrational number gives us an irrational number. However, if we operate two irrational numbers, plus minus into divide, then the resultant number may not be an irrational number, So suppose you take 4 plus root 3 plus 4 minus root 3. This will give me 8, a rational number. Irrational plus irrational, rational. 4 root 3 by 2 root 3. Root 3 cancel, it gives me a rational number. 4 root 3 into 2 root 3. 8 into root 3 into root 3 is 3 is 24. It is a rational number. Okay. So if we operate two irrational numbers, we may not get an irrational number. We can get a rational number. But this is not the case with the rational numbers. If we operate two rational numbers, we will always get a rational number. If we operate two rational numbers, then we will always get a rational number. Always. If you add two integers, you get an integer. If you add two fractions, the resulting will also be a fraction, and so on and so forth. And therefore, we say that the irrational numbers are not closed. Irrational numbers are not closed. Or we can say that they do not satisfy the closure property. So, irrational numbers do not satisfy the closure property. Do not satisfy the closure property. That means if I add two irrational numbers, I am not sure that I will get an irrational number, whereas that is not the case for rational numbers. Okay, fine. Now we have done the insertion of rational numbers. Now if we are asked to insert irrational number, suppose if I say A and B, both A and B belong to Q, means A and B are rational numbers. This is one belongs to. A and B are rational numbers. Then root over AB is an irrational number, provided AB is not a perfect square. AB is not a perfect square. Suppose for example, if they give you find two rational numbers, question says find two irrational numbers between 2 and 2.5. So what will the first one will be 2 into 2.5. So this is root 5, correct? And again we can say the second one will be 2 into root 5, that is root over of 2 root 5. So if I draw the number line, what will I see? If I draw the number line, what will I see? That if this is 2 and if suppose it is 2.5, then root 5 will be somewhere here, 2 root 5 will be somewhere here, root 5, yes, root 5 and yes. And again, if I want to find irrational number between this and this, I can again take a number between this and this will give me 2 into square root of 2 root 5, and it will continue like this. So we can say that there are uncountably infinite irrational numbers between two rational numbers. At the same time, there are uncountably irrational numbers between two irrational numbers. Because I can find an irrational number between this and this by taking square root of what? 2 root 5 into root 5. 2 root 5 into root 5. So what? Root 10. So this is my root 10. Right now? So we can say that there are uncountably infinite irrational numbers between two rational numbers and two irrational numbers. Okay, is it clear to all of you? Now this together, rational number and irrational number, constitutes the number line. This together the rational numbers and the irrational numbers constitute the real numbers, and any point on a number line will correspond to either an infinite number, either a rational or irrational number. So that means if I draw the number line and it is 0, 1, 2, 3, these are all rational numbers. We know integers are rational numbers. And if I take any point in between, any point, it can be 0.5 or it can be root over of something. If I take any point 1.5, if it is 1.5, or if I take it is root over 2. So any point on a real number line will either correspond to a rational number or an irrational number. Okay, fine. So in the next lecture we will see how to prove the irrationality of a number. So thank you.